We have already discussed Dalton's model of an atom and Thomson's model of an atom, which he called the plum pudding model. After 10 years of Thomson's model proposal, two of Ernest Rutherford's students were doing an experiment with radiation. They were using the dense, positively charged particles, which are called the alpha particles, as bullets to fire a very thin piece of gold foil. So this is the gold foil. Actually, they expected that the particles would directly hit the gold atoms, according to Thomson's model. However, they got surprised. When they started firing these alpha particles, the radioactive detector shows that most of the alpha particles passed through the foil. However, when they moved the detector, they found that some of the alpha particles are deflected by the foil. Moreover, some of these particles bounce off the foil. So some particles passed through the gold foil, others were deflected, and others were bounced off. What does this mean? Well, in 1911, Ernest Rutherford interpreted these results and suggested a new model for the atom. So this is the new model of Rutherford. Since Thomson's model was not correct, he suggested that the positive charges must be concentrated as a small volume in the center of the atom. Otherwise, the heavy alpha particles fired at the foil could never be repelled back towards their source. In this model, the electrons orbited around the dense nucleus. And we know that the nucleus is the center of an atom where we have the positive charges, and the negatively charged electrons will be orbiting around the nucleus. The next important development emerged in 1914 when Niels Bohr revised the model again. It has been known that the light given out when atoms were heated always had specific amounts of energy, but no one had been able to explain this. So Bohr suggested that the electron must be orbiting around the nucleus, which is the center of the atom, at certain fixed energy levels called shells. So these are the shells or the energy levels. So this electron is orbiting in shell number 1, and energy must be released when the excited electron falls from a high energy level to a low energy level. So when they move from shell 1 to 2, energy is released, and when they move from shell 2 to 3, energy will be released as well. However, if the electrons moved from shell 3 to 2, then the energy will be absorbed, and same case if they moved from shell 2 to 1.